Alright, what's up, Professor Dingler? We're here, about to watch your Super Mario World Credits Warp explained video. And, I think it's pretty cool that you picked a Mario video. I've watched a lot of, if you've seen the original, Super Mario Bros., all the world record and speedrun stuff on that. And, there's, a lot of glitches that go into that as well. And, I've watched similar videos about that original Mario. I've never watched one about Super Mario World, but I remember playing that game back as a kid. I've got a grapefruit sparkling water, and I'm gonna crack this open and let's get into it.
The credits warp in Super Mario World is a very complex and intricate glitch that involves executing arbitrary code that is written by the player in-game. A summary of the route goes like this.
Written
Write
by the
some code
player?
using Koopa shells, set up some pointers by manipulating sprites, then perform a glitch that will allow the code to be executed in real time. Before we jump into the route, there are a few things that need to be explained about the game first that will make understanding this a bit easier. In Super Mario World, there can only be 12 sprites loaded in memory at one time. We can represent these 12 sprites as being in slots, which we'll show as these boxes. The slots are numbered 0 through 11, with 0 being the first slot and 11 being the last. Notice that slots 10 and 11 are different. In Yoshi's Island 2, these slots are reserved for special sprites such as berries and items coming out of the item box. Since it's relevant, we'll display the low byte of the sprite's Y position on the left and its X position on the right.
Why isn't it a base of 2?
Its Y position will increase as the sprite moves downward, and the X position will increase as the sprite moves to the right. Since we're only looking at the low byte, as soon as we hit the highest value, FF, it'll roll back over to 0. Also, when a sprite is being eaten by Yoshi, we'll show that with this little icon. When a sprite is loaded, it will generally try to spawn into the highest numbered slot available. Special sprites will start looking at slot 11, and normal sprites will start looking at slot 9. If all the slots are full, the sprite gives up and doesn't spawn at all. When a sprite is unloaded, it is removed from the slot, but its old position values are still present. These aren't overwritten until another sprite spawns in that slot. Everything in the game is stored as numbers, data, instructions, and operands alike. This means we can interpret a sequence of bytes as code in different ways. In this case, we are reading the sequence of X positions of sprites as code. However, depending on where we start from, the sequence can be interpreted into very different code. For example, consider the following data. Reading this as code starting from the first, second, and third bytes results in very different assembly code. In order to execute the code we want, we need to make sure we start reading this code at the correct starting position. Keep this in mind for later when we get to the actual route.
About computer science.
There's a register in the SNES hardware that keeps track of every read and write that occurs, called the Memory Data Register, or MDR. We call the value it holds the open bus value, or data bus. If an address that is not mapped to any kind of memory is attempted to be read or written, the data bus is not updated. If execution jumps to an unmapped address, it will instead jump to open bus, which can act very strangely, as we'll see later. With that knowledge, let us begin with the actual route.
Go. What is actually going on? Credits warp. Just show us the thing. I don't know what's going on right now.
First, we'll go and get Yoshi. We'll kick this shell out of the way so that Yoshi spawns into slot 8. The message box you see on the right
is 12 really enough? I feel like
slot 8 will now always be filled because Yoshi will not despawn at all during the route.
Like little Koopas,
next,
that's like everything.
We'll set up the code we want to execute by using the X positions of the Koopas that spawn in slots 0 through 5. The way these values come to be doesn't really matter as long as they're all there in the end. When a Koopa is eaten by Yoshi, its X position is set just after Yoshi spits it out, then the sprite despawns. This lets us write the code without other Koopas spawning in and overwriting anything. You'll notice the Y positions stay as well. They're important too, but we'll see why later. Normally when Yoshi eats a berry, it turns into a sprite for a small amount of time before it is eaten and despawned. However, if we glitch them like this, the sprite will never despawn. Since berries are special sprites, they'll spawn into slots 10 and 11. And since they'll never despawn, slots 10 and 11 will eventually always be filled, forcing other sprites to spawn in lower number slots. We collect the mushroom so that we can force the P-switch into slot 6. Since we glitched the berries and the special slots are full, the mushroom will go into slot 7 when we release it. Then we load the P-switch until slot 6. Now we need to place the P-switch to set its X position. First, we break these blocks because they're in the way and collect these coins. The coins are in the way because the sparkles they leave behind will overwrite important values later. We'll place the P-switch at X position FF on screen OE. This is also important for later.
Then why doesn't that
Next,
despawn
we'll break
when you
this
leave?
block with a spin jump in order to make some minor extended sprites appear, the little brick particles. These particles are stored in another table similar to the sprites, but I've simplified it by only showing the Y positions of these particles. When these minor extended sprites go off the screen, they despawn and leave their position values behind. We need the bottom left particle to despawn at 0, 0 exactly, and the top right particle to despawn somewhere between D8 and E4. These values will be treated as a jump address in the code. The code we wrote earlier with the shells starts at 0, 0,
This is the most
E4.
in-depth bug I've ever seen in my
we can also
life.
jump a little bit before the address and make our way there, as long as the code is safe and won't crash.
Who
The
came
Y
up with this?
positions
I
of
need
the
to know.
sprites starts at 0, 0, D8. This is why the Y positions of the shells are important. If the value of the particle isn't exactly E4, it will run through those values as code as well. There are a few complications with the block break and its particles. First of all, there are 4 different sizes of explosions, only one of which can give us the values 0, 0, and E4. Second, the particles move faster than 1 pixel per frame, which means we can only get the values D8, DA, DC, DE, E0, and E3. Remember these for later. Finally, we perform the item swap, which triggers the entire thing. The reason the item swap works is because of how sprite spawning works and the fact that the game doesn't erase the flag that Yoshi is eating a sprite when it is
You can just
destroyed.
spawn that?
We release the mushroom from the item box and it goes into slot 9. We let Yoshi eat it, but collect it before he can swallow it. Now that the screen scrolled a bit to the right, the Chuck can spawn in. He spawns into slot 9 as well. And since the mushroom was on
Why did the
Yoshi's
guy
tongue when it was
spawn?
collected, the Chuck will also be on Yoshi's tongue when it spawns.
Oh.
This means that Yoshi eats the Chuck, and so it begins. The game never considered what to do when Yoshi eats a Chuck because you can't normally eat them in the first place. It just so happens that the game jumps to address 014A13 because it doesn't know what to do exactly. Remember that it normally jumps to a subroutine that gives Mario a power-up, then returns execution here. So we need to return here at some point, somehow. Now
Where's this getting written
014A13
then?
happens to not be mapped to
Actually
any
don't
type
know.
of memory, so we go to Open Bus instead. Now the data bus contains
This is important. I'm looking this up. What was Super Mario World written in? Assembly? No. Higher level languages like C? That's crazy. I forgot they were like doing that like back
one
in the day.
because of the highest byte
It
of
wasn't
that
just
address
Roller
it just
Coaster
tried to jump to.
Tycoon.
So the next
That's so
instruction to
crazy.
execute will be
I
as
had
if there
enough
is a
pain and
continuous
suffering
stream of
with
this
our,
number. The first instruction
bubble
of this
sword.
stream of O1s can be read as ORA indirectly at address O1 indexed with X. The sprite Yoshi tried to eat,
This really
Chuck,
gets into
is
it,
in
though.
slot 9, so
Holy-
X has a
holy
value
crap.
of 9. This makes
It's
the
just
instruction
all
ORA
code.
indirectly at address OA. This is an indirect address, so we need to look at what value
I don't even
is
know,
in
like,
OA. This happens to
should
be
have
the X
shown the,
position of the sprite in the lowest
bug at
number
the
of sprite
beginning.
slot,
I don't
plus
even
2.
really know.
The P-switch is in slot 6, so we take its X position,
What's the plot here?
OEFF, and add 2, which makes OF01. Finally, that makes our instruction ORA address OF01. Now, address OF01 corresponds to this tile on the status bar. If there's a dragon coin icon there, it will be 2E, but if it is still blank, it'll be FC, which is what we want. Because we read the value of this address,
Somebody
the
really
data bus
came up
has
with
now
this, dude.
become
Someone
FC.
was like,
What is the next instruction
that's a
to
little
execute?
weird.
Well, if you learned from before, you may think that because of a continuous stream of
Like, what would
FCs,
prompt
that it
someone
would be
to come up with, like,
JSR
figure this
indirectly
out?
address FCFC indexed with
It
X.
would have to
That's
be
close,
speedrunning,
but
and
this is a
there's no-
jumping
there's no
instruction,
other-
so the return address will be pushed to the stack,
no other
which also
motivator.
affects the open bus value. This jump instruction was 4 bytes long, so the program
Yeah, like, what
counter
does
gets
this guy do? Freeze. What are you up to, bro?
Yoshi clips.
Speedrun,
They're
I knew it.
frustrating.
I
to
called
make yourself
it.
feel better, you can't
I called it. That's the only thing that would motivate someone to figure out something this convoluted. It's just nice. It's not just me. It's not
It's
just me.
incremented from 4A13 to
This is
4A17.
ridiculous.
First,
Like, are
the
you
low
kidding me?
byte of the jump instruction is read. This is FC because of the data bus value. Next, the high byte of the return address is pushed to the stack, which makes the data bus value 4A. Then the low byte, 17. Finally, the high byte of the jump address is read, which is now 17 from the previous cycle. This translates to JSR indirectly at address 17FC indexed with X. Now, X has not been modified since last time, so it is still 9, which gives us JSR indirectly at address 1805. 1805 is the address in memory where the block particle's Y positions are stored. Execution will jump to the address that is contained in this location. Remember how the block particles could be a range of values?
So can you do anything with
1806
this
should
bug?
always
Just
be
program
0,
what you
but
want?
1805 can be D8, DA,
With, like, special
DC, DE,
sprites?
E0, or E3. In the best
I
case, the
guess
value should
credits
be
warp,
EO
that's
or
gotta
E3,
be the most OP
since
thing
the
you can
code
do,
rewrote
right?
will
Just
be
warp
guaranteed
straight
to
to the
execute the way we want
straight
it.
to the end
If
credits.
the value is not one of those two, there may be problems with how the sprite's Y positions are read as code, but we might get lucky. In this video, the Y positions happen to be these values. Read as code from any of the possible values from 1805, we get this. In this case, we weren't lucky at all, as the last two values are the only ones that would make it through. We can modify these values by
Man, I
jumping
missed
at
the
different
golden
heights when
age of
spitting out the
computer
shells with
science.
Yoshi, but there's no easy
Crazy
way
they
to do
coded
this
this in
consistently.
assembly.
The
And then
value
someone,
of
like, looked at the
1805
assembly
was
to figure
E0
this
in this
out.
video, so we're good
Now
to
all
go.
I do is I just
Eventually
prompt-
and hopefully,
I just
the code
prompt
will make its way to
ChatGPT,
E4,
and
which is the beginning of our
that's it.
code. The
I'm
values
literally-
we
I'm
set
born,
up
like, 20 years
correspond to
too
this
late. It's
assembly
actually
code.
horrible.
Load to the accumulator 1C, store from the accumulator indirectly at address 75,
Like, this
and
is
jump
beautiful.
to address
kidding
FF46. The number 1C is a game mode that makes the game fade the screen out and go to Yoshi's house in the credits. Address 75 has a value of 1
They
if
just
Mario is
load
swimming
the
and 0
credits
if he
into
isn't.
memory?
And address
Really?
76 is 1 if Mario is facing right and 0 if he's facing left. We want to store our 1C into address 0100, which is where the current game mode is stored. Therefore, Mario must not be swimming and he must be facing right. Now that's all finished, but remember from a while ago that we still need to return back to where we swallowed Chuck. How do we do that? Well, we can't just use a return statement because we have a bad return address on the stack, and we don't have enough sprite slots to remove them before returning. So instead, we jump somewhere in the original game code that'll do it for us. The address 01FF46 is a sprite graphics routine that has something to do with drawing Iggy to the screen. What's important is that it has two PLX instructions in the middle of its loop. Since we jumped into the middle of the loop, two extra PLX instructions will be executed, which means the bad return address will be gone by the time this subroutine returns itself. We just have to wait for it to finish, and the game handles the rest automatically. It's also this part of the glitch that causes all the glitchy graphics to appear on the screen during the fade out. I hope you now have a general idea of what is going on behind the scenes during the Super Mario World credits warp. Thanks for watching.
Show me the credits warp. Did I, like, miss it? What, like, is it? This guy dove straight in to... I need to, like, actually see it. He dove straight in. Way too fast. Super Mario World credits warp. I just want to see, like, an unedited... No, I don't need another 8-minute video. Jesus Christ. Here we go. This is what it came out for. Yeah. 41-second speedrun. I actually missed the golden age of everything. So. Imagine when this dropped, man. And, like, if you were, like, a CSGO, you knew they just wrote this entire thing in assembly. You just, like, dissected. Like, I'll figure it out. We can warp straight to the credits, bro. We'll beat this. We'll beat this in 30 seconds, man. You do it immediately. Like, you just load into the world. Yeah, look at this guy go. Oh my god, this is beautiful. Yeah, he's doing the same fireball thing. That's beautiful. I think it's a little different than what the other guy did, but I get the point. You see, he should have played that. He should have played that at the beginning of his video and then been like, what's going on? Game gets completed during the intro. Yeah, literally. That's beautiful. Nintendo put in millions of dollars slaving away at the assembly for someone to reverse engineer and beat the game in 30 seconds. Wow. Yeah, I feel like I reacted. I'm like halfway down my sparkling water. Hope you enjoyed this reaction among watching like what, like 100 of these, if you even watch them. But all right, thanks for the semester. Hopefully, I'm gonna go start studying for this final. Hopefully, I do half decent on that. All right, goodbye.